Hello everyone. In today's lecture, we are going to see two quantities, that is distance and displacement. Now, as we have already studied in the types of motion, right, that is a body when it is changing its position with respect to time, we call it as motion. So, when it changes its position with respect to time, two quantities must be considered, that is distance and displacement. So, when the body is changing its position, there is a distance covered by the body, as also there is a displacement of the body. Displacement means from one position to another position. Okay. So, let us see, using one example or considering one example over here, what is the difference between distance and displacement, and what is a distance and what is a displacement, right. So, the example is, suppose a body is at position A, okay, and the body moves to position B, but the path over here can be anything. So, let us consider this as the path, okay. So, as you can see, this is the path from A to B. So, the distance over here is nothing but the length of the path, okay, the length of the path traversed by the body. But whereas the displacement is the shortest distance between initial and final position, that is initial position is A and final position is B, okay. So, distance is nothing but the length of the path traced by the body, and displacement is the shortest distance between the initial and final position of the body during the entire motion, okay. So, let us define it. What is distance? So, distance is the length of the path traversed by the body. Traversed means covered or travelled, okay, traversed by the body during the motion, okay, during the motion. But the displacement is the shortest distance covered by the body between the initial and final position during the motion, I hope you got that, right. So, distance is nothing but the length of the path traversed by the body during the motion, and displacement is the shortest distance between, or the shortest distance covered by the body between the initial and final position during the motion. As you can see over here, A to B, this one over here is the displacement, okay, that is A to B, shortest distance, okay, and this one over here, which is the actual path, and the length of that path over here is distance, right. So, distance, the length of the path traversed by the body during the motion is distance, and displacement is nothing but the shortest distance between the initial and final position of the body during the motion. I hope you got the difference and the definition, right? Now, let's solve some problems, okay, based on distance and displacement, so the concept of distance and displacement would be clear to you. Now, here's the first question for you. A wheel of radius 1 meter rolls forward half a revolution or a horizontal ground. The magnitude of the displacement of the point of the wheel initially in contact with the ground is. Now, they are saying that there is a wheel of radius 1 meter. So, let's draw it, okay. So, this is the horizontal ground, okay. Now, the wheel of radius 1 meter. Let's draw the wheel also. So, suppose this is the wheel, okay, and the radius is 1 meter, okay, radius is 1 meter. So, rolls forward half a revolution. Half a revolution means not complete but half. So, as you can see, if I draw the point which is in contact with the ground, so after half revolution, suppose it is somewhere over here, okay, suppose it is somewhere over here. Now, I hope you can imagine if I tell you that after half revolution, this point, suppose this point is A, okay, after one complete rotation, the point A would be exactly on the ground floor again, I mean on the horizontal ground, isn't it, in contact with the horizontal ground. But half revolution means it would be somewhere over here, right. So, this is our point A. If it is full, the point A after revolution would be back into the same position, but it is only half. So, it should be over here. So, now as you can see, initially it was over here, okay, initially, let us write that initially, and this is finally. So, they are asking what is the magnitude of the displacement of the point of the wheel initially in contact with the ground. So, initially it was over here and finally it is here. So, as the radius is 1 meter, so can you tell me what is this total distance? This is nothing but diameter. So, diameter is 2 meter, isn't it? So, now over here you can observe two things, that is the distance travelled by the point A which was in contact with the ground and the displacement. So, displacement is nothing but shortest distance between initial and final position. So, over here displacement would be the shortest distance between initial and final, that is nothing but the diameter, that is 2 meter, isn't it, that is 2 meter. And over here if I ask you in addition, what is the distance travelled by the point A which was initially in contact with the ground, that is half the circumference of the wheel, and that is nothing but pi r, that is nothing but pi r, that is nothing but simply pi into 1, right, pi into 1, simply that is pi meter. Can we say that? Of course we can, okay. So, I hope that is clear to you. Now, let us see one more question. As you can see the second question over here, an athlete completes one round of circular track of radius r in 40 seconds. What will be his displacement at the end of 2 minutes 20 seconds? Now, over here they are asking you what is the displacement, and there is a circular track of radius r, right. So, let us draw that. So, suppose this is the circular track of radius r, and let us assume that this is the starting point, okay, this is the starting point, okay. Now, this is the starting point, right, okay. Now, an athlete completes one round of circular track of radius r in 40 seconds. So, in 40 seconds he completes one circular track. So, we know the circumference or the length of the circular track would be 2 pi r, isn't it, 2 pi r. So, in order to cover 2 pi r, it takes 40 seconds. It takes 40 seconds. So what will be his displacement at the end of 2 minute 20 seconds? So 2 minute 20 seconds means 2 minute 20 seconds means 2 minute means 60 seconds, 1 minute. So 2 minutes 120 seconds, 120 plus 20, 140 seconds, isn't it? 140 seconds. So 140 seconds is the total time, and it only takes 40 seconds to complete one track or one circular track. So in 140 seconds, how many times he will cover the circular track? So let's divide it. So 140 divided by 40. What is that? Simply we can write 7, 2 7s are 14, 2 2s are, and this is nothing but 3.5. So 3.5. So 3.5 times he will cover the track. It means in 140 seconds he will cover 3 times and 0.5 times. So 0.5 means half. So in 40 seconds he covers one circular track. So in 120 he will cover 3 times, and in last 20 seconds he will only cover half, isn't it? 40 plus 40, 80 plus 40, 120 plus 20, that is 140, right? So this is his final position. This is his final position. So what is the displacement over here? What will be his displacement? That is the question over here. And displacement is nothing but the shortest distance between initial, that is starting point, and final point. So over here, as you can see, this is nothing but the diameter, right? It is nothing but diameter. So over here, of course, over here you have to consider the speed to be constant. Then only you can say that, yeah, in 40 seconds if it covers, or if he covers the total track, in 20 seconds he will cover half of the track. So over here, as you can see, this is nothing but diameter, and diameter of circular track radius r is nothing but 2r, isn't it? So what is our answer? That is 2r. I hope you got that. So that was all about our introduction to distance and displacement. I hope you got that. Thank you.